This will be an example of using your Milltronics control for creating a conversational program to be used on either your ML or your SL using the Trig help function. First, we're going to want to select F8 Program, F2 Conversational Edit, F2 New. Using the supplied sample print, the title on that is Tapered Bore, so that's what we'll name our file. You can either name it letters or numbers. Hit enter. And now if you want to name your program again, you can do so. It's not required. You can program in inch or metric. And now we will define our solid model, your length, diameter, and your ID. So material length off of the print is 4 inches, your OD is 4 inches, and the ID is 1. If it's solid stock, you can just leave that field blank. If you want to write any additional notes, you can do so on these lines. Select F1 Store. So the first event we're going to want to do is a tool change, which will be F7. Our tool number will be 1. You don't have to write your description, but we'll write boring bar. And you can program in feet per rev or per minute. We'll program in feet per rev. And we'll select 12 thou for our feet per rev. And your spindle can run in constant surface speed or RPM. We'll select constant surface speed. And if you want to set your max spindle RPM, we'll set it at 1500. And our constant surface speed for this material will be 350. And your stop command, if you're running multiple tools and you want a program stop or optional stop anywhere throughout the program, you can select either one of these here, or if you don't want any stop, you can just select that. Now your spindle direction, clockwise or counterclockwise, and if you want your coolant to come on, we will select coolant on. Once all that information is filled out, select F1 Store. And now we will select the operation we want to do. If you want to turn it, face it, thread, drill, grooving, this will be a turning cycle. So we will select Start. And the type, you have two choices, rough turning or pattern repeat. For this example, we'll use a rough turning setup. And our first two fields of information are X and Z finish stock. In these fields, you're going to want to write an amount if you want to come back with the finishing tool after you rough it out. This is how much you'll take with your finishing tool. If you put both of these at 0, the roughing tool is going to cut it to your programmed dimensions. And your X and Z rough stock is how much material you're going to cut on your final pass with your roughing tool. So it's going to remove 10 thou on X and 5 thou on Z to get it to your final dimension. First X depth, I will put 1 inch for being the 1 inch ID and the cut increment of 100 thou. Clearance 50 thou. Compensation if you want it off, left or right. If you're doing different geometries with different radiuses and steps, depending on which side of the feature you're on, that's going to determine how you want your cutter comp. For this example, we'll leave it on left, or off, sorry. And our start point, we'll go to 0.9 on X and 0.1 on Z. And our pattern number, we'll just match our pattern number with our tool number. And what the pattern number does is it associates all the lines after this cycle to this pattern. So if we come back later in the program and we want to do this profile again, we don't have to type every line. We can just say repeat pattern 1, and it's going to follow all our lines of geometry that we're going to create. So select F1 Store. Now we're going to give it the geometry that is given to us on our print. So select F2 Line, and we're already in our feed rate. So we can hit enter down to our X field. So we know our X dimension is 3.5. And our Z is 0.1 where we're going to be starting. F1 store. I'll give it another line, F2. Hit enter down to our Z, and we know that first movement goes back to 1/2 inch. Select F1 store. Now select line again. Now this line goes at an angle. We know the angle, but we don't know the point where the line is going to end to. So we're going to hit enter down to coordinates, and we're going to toggle to polar. So we're going to make a polar line. And the line length, we're just going to estimate it to be 2 inches. It doesn't have to be exact. Using the Trig help function, it's going to find the intersections. So we're going to estimate the line length at 2 inches. And now we have to figure out the angle. So the angle is based off of the current position you're sitting on, which will be at -0.5 on Z. So using the polar coordinates, if you're looking at your current position like the face of the clock, 3 o'clock would be 0 degrees, 12 o'clock would be 90, 9 o'clock would be 180, 6 o'clock would be 270. So our line is going to be basically 270 minus 30. So that's going to get it to be a 240 degree line. Select F1 store. Now we're going to select another line. And now as you look on your print, we know the next line is going to be a 15 degree line, but we don't know where that intersection point is, but we know where the following line is. So we're going to write that line as an X of 1 inch and a Z of -2 inches. Then we're going to hit enter, and one more time to get down to extend back. And in extend back, we're going to select short, and we're going to select the angle of that line, which would be 15 degrees. And select F1 store. And now another line from that point, just to go back to the end of the part, which would be -4 inches. So there's our -4 inch line on Z, and select F1 store. Now our pattern is done, so we're going to want to end it, F6. Store it. So our program is now complete. I'm going to hit escape. When the program is done, it automatically shuts the spindle and the coolant off. I'm going to hit escape one more time to get back to our main page. We're on our main page. And from here we're going to verify our program. So we're going to select F9 verify, F7 menu. Then we're going to look for the name of our program, which is Tapered bore. Select F1, F1 start, and now Alt and F6 to start from the beginning. Alt and F6 to simulate the tool change. On your machine you wouldn't have to do this, of course. So there in our solid model graphics you see the bore. We're going to select F6 display, F1 rotate, and ZX view, and escape again. And there's a few different modes you can go into here. Here's a semi-transparent. You can just do a wireframe if you want to see your lines of geometry. We're going to hit escape one more time. Select F9 verify, start. So there you can see your part being created. It gives you an estimated cycle time. And you can always hit F6 display, solid, and go through your different modes of your graphics, and you can rotate it also, isometric view. So that is how the Milltronics control handles the Trig help and extend back functions on either an ML or an SL. Thank you.